Have you ever wondered what would happen if humanity's greatest scientific minds discovered something so extraordinary that it could rewrite our understanding of intelligence in the universe? Well, that moment might be unfolding right now, and most people have no idea. What I'm about to share with you tonight will challenge everything you thought you knew about our cosmic neighborhood. After diving deep into classified research papers, telescope observations from around the globe, and yes, even the most controversial theories that have Harvard astrophysicists questioning whether we're witnessing humanity's first confirmed alien visitor, I can tell you that the object designated 3IAtlas is far more mysterious than anyone initially realized. We'll uncover why this interstellar wanderer defies every law of celestial mechanics we understand, why the James Webb Space Telescope detected chemical signatures that shouldn't exist in natural space objects, and how a brilliant but polarizing physicist has convinced half the scientific community that we might be under extraterrestrial surveillance right now. But that's just the beginning. The deeper we dig tonight, the more this cosmic mystery reveals itself to be something that could fundamentally change humanity's place in the universe. From its impossibly precise trajectory that mathematically shouldn't exist, to the explosive implications that have government agencies quietly taking notice. This is a journey through one of the most captivating scientific puzzles of our time, where cutting-edge astronomy meets the profound question of whether we're truly alone. And I'm here to guide you through every mind-bending detail, every statistical anomaly, and every piece of evidence that's building toward a conclusion that might just redefine what it means to be human in this vast cosmos. Trust me, the longer you stay with me tonight, the more extraordinary this story becomes, building toward revelations that will leave you questioning everything you thought you knew about visitors from the stars. If these deep dives into cosmic mysteries fascinate you, it would mean the world to me if you could share a like and perhaps subscribe to join our growing community of curious minds who aren't afraid to explore the impossible. I love hearing from you in the comments about where in this incredible world you're watching from tonight and what time it is in your corner of our spinning planet. Now, let us begin our descent into one of the most compelling scientific detective stories of the 21st century. On July 1st, 2025, at precisely 11:37 Universal Coordinated Time, something happened that would soon capture the imagination of astronomers worldwide and ignite debates that continue to this day. The asteroid terrestrial impact. Last Alert System, operating from its mountain observatory in Chile, detected a faint point of light moving against the stellar background in a way that seemed, at first glance, unremarkable. But sometimes the most profound discoveries begin with the quietest observations. The telescope operators, following standard protocols, recorded the object's position and brightness, assigning it the temporary designation that would later become famous as 3IAtlas. In those first moments, no one suspected they were potentially witnessing the arrival of something that would challenge our most fundamental assumptions about intelligence in the cosmos. Think about that for a moment. In our age of instant global communication and constant digital noise, here was a cosmic messenger that had potentially been traveling through the void for billions of years, carrying secrets from stellar neighborhoods that existed before our own sun had even begun to shine. And its grand entrance into our awareness was marked by nothing more than a few pixels, changing brightness on a computer screen in the Atacama Desert. Within hours of that initial detection, something remarkable began to unfold. Additional observations from telescopes scattered across the globe started to paint a picture that was both familiar and deeply unsettling. The object was moving fast, far too fast for anything gravitationally bound to our solar system. Its trajectory curved through space in the distinctive hyperbolic arc that astronomers recognize as the signature of an interstellar visitor, an object that has come from somewhere else entirely and will eventually return to the cosmic ocean between the stars. But here's where our story takes its first curious turn. When astronomers began tracing backwards through archival images, searching for earlier glimpses of this mysterious wanderer, they discovered that 3IAtlas had been photographed before, multiple times, dating back weeks earlier. The Zwicky Transient Facility at Palomar Observatory in California had captured its image, as had several other observatories stationed around the world. These pre-discovery observations revealed something that made seasoned researchers pause and recalculate their assumptions. The object had been approaching our solar system for an extended period before anyone realized what they were seeing. It had been hiding, in a sense, in plain sight among the countless points of light that dance across our detector arrays each night. This delayed recognition speaks to something profound about the nature of cosmic visitors and our ability to perceive them. How many other mysterious travelers might be gliding through our neighborhood right now, waiting patiently for the right combination of observation and insight to reveal their true nature? As the mathematical analysis deepened, astronomers around the world began to appreciate the truly extraordinary nature of what they were witnessing. This wasn't just another chunk of ancient ice and rock ejected from some distant stellar system. 3IAtlas displayed characteristics that set it apart from its predecessors in ways that challenged conventional understanding. The famous Oumuamua had appeared in 2017 like a cosmic messenger that arrived too quickly and departed too soon for us to fully grasp its secrets. The second confirmed interstellar visitor, 2I Borisov, had visited in 2019 and behaved more like a traditional comet, complete with the expected tale of gas and dust that astronomers found reassuring in its familiarity. Now we had 3IAtlas, and this visitor was presenting us with a puzzle that had implications extending far beyond simple astronomical curiosity. It was larger than Oumuamua, potentially much larger, yet it displayed cometary activity in ways that seemed almost restrained, as if it were revealing just enough of its true nature to satisfy our observations while keeping its deeper secrets carefully concealed. The size estimates began at approximately 20 kilometers in diameter, making it potentially the largest interstellar object ever detected passing through our solar system. But as more sophisticated observations began to refine these measurements, something curious happened. The estimated size kept fluctuating, first shrinking to 10 kilometers, then to approximately 6 kilometers, with some analyses suggesting it could be as small as 3 kilometers across. This uncertainty in size estimate speaks to the fundamental challenge of studying interstellar visitors. We're essentially trying to understand objects that exist at the very edge of our observational capabilities, cosmic shadows that reveal themselves only through the faintest traces of reflected sunlight and gravitational influence. But perhaps the most intriguing aspect of 3IAtlas wasn't what we could measure about it, but what we could calculate about its journey. The trajectory analysis revealed something that sent ripples of excitement and bewilderment through the astronomical community worldwide. This object wasn't following a random path through our solar system. Instead, it was executing what could only be described as a grand tour of our planetary neighborhood, approaching remarkably close to 3 of our most significant worlds with mathematical precision that defied explanation. The numbers were stunning in their implications. 3IAtlas would pass within approximately 29 million kilometers of Mars, sweep past Venus at a similarly intimate distance, and make a relatively close approach to Jupiter, the gravitational giant that shepherds our outer solar system. When astronomers calculated the probability of such a trajectory occurring purely by chance, they arrived at a number that was almost impossibly small. According to Harvard astrophysicist Avi Loeb, whose previous work on Oumuamua had sparked intense debate within the scientific community, the odds of a randomly oriented interstellar object naturally following such a path were less than 0.005%. In the language of statistics, this represents what researchers call a statistically significant anomaly, meaning it's so unlikely to happen by accident that we must seriously consider alternative explanations. Let me put this in perspective for you. Imagine throwing a dart at a map of our solar system from a distance of several light years. The chances of that dart following a path that just happens to provide optimal observation opportunities of multiple planets would be vanishingly small. Yet that's essentially what 3IAtlas appears to have accomplished. This statistical impossibility began to capture imaginations beyond the quiet halls of observatories and research institutions. In an era when the search for extraterrestrial intelligence has moved from the fringes of science into mainstream academic pursuit, when government agencies have begun acknowledging the reality of unidentified aerial phenomena, the possibility that 3IAtlas might represent something more than a natural cosmic wanderer began to seem less like science fiction and more like a legitimate scientific hypothesis worthy of serious consideration. The timing of the discovery added another layer of intrigue to the unfolding mystery. July 2025 fell during a period of unprecedented openness regarding the possibility of non-human intelligence. Government reports about unidentified aerial phenomena, congressional hearings, and official acknowledgements of unexplained encounters had created a cultural moment where questions about extraterrestrial visitors were being discussed with a seriousness that would have been unimaginable just a few years earlier. But before we delve deeper into the implications of what 3IAtlas might represent, let's examine the physical characteristics that have made this object so fascinating to researchers worldwide. Unlike typical comets, which usually display obvious signs of gas and dust emission as they approach our Sun, 3IAtlas has been remarkably subtle in its activity. The object displays what astronomers describe as a compact coma, the characteristic cloud of material that surrounds an active comet nucleus. But this coma appears restrained and controlled compared to what might be expected from a natural object of its estimated size. This understated behavior became one of many small mysteries that would accumulate around 3IAtlas as observations continued. Spectroscopic observations, which allow astronomers to analyze the chemical composition of distant objects by studying specific wavelengths of light, began to reveal another puzzle. The James Webb Space Telescope, humanity's most advanced infrared observatory, detected emissions that were dominated by carbon dioxide rather than the water vapor typically expected from natural comets. Even more intriguing, the spectroscopic analysis revealed chemical signatures that included compounds like cyanide and nickel, but notably absent was iron, despite the fact that iron and nickel typically form together in the cosmic furnaces of exploding stars. This unusual chemical fingerprint resembled what you might expect from industrial processes, rather than natural astrophysical phenomena. The mystery deepened when NASA's Transiting Exoplanet Survey satellite detected a persistent glow around the object as early as May 2025, when it was still 6 astronomical units from our Sun, far too distant for normal water ice sublimation to occur. The object also exhibited what astronomers call an anti-tail, a faint appendage pointing directly away from our Sun in a configuration that defies typical cometary behavior patterns. These accumulated anomalies led some researchers to calculate that there was less than a 0.2% chance that 3IAtlas represented a naturally occurring space object, though the vast majority of astronomers remained skeptical of any artificial origin hypothesis. What truly sets this cosmic visitor apart, however, is its behavior as it navigates through our solar system. Most asteroids and comets follow predictable paths determined entirely by gravitational forces, dancing to the invisible choreography of celestial mechanics that Newton first described centuries ago. But 3IAtlas has exhibited subtle course corrections that suggest something far more intriguing than simple gravitational influence. These tiny adjustments to its trajectory could theoretically be explained by outgassing from its surface, the natural process where solar heating causes volatile materials to sublimate and create small propulsive forces. But they could equally well indicate something that would fundamentally change our understanding of what's possible in the cosmos. Active guidance systems maintaining a predetermined flight path. The retrograde nature of its orbit adds yet another layer to this deepening mystery. 3IAtlas is moving opposite to the direction of planetary motion, giving it a relative velocity of approximately 98 kilometers per second when it passes closest to Earth. This retrograde approach provides several tactical advantages that would be invaluable to any intelligence-gathering mission. Advantages so specific that they seem almost too convenient to be coincidental. First, the extraordinarily high relative velocity makes interception by human spacecraft virtually impossible with our current technology. Our most capable rockets can achieve velocities of perhaps 20 kilometers per second, falling far short of what would be needed to rendezvous with this rapidly moving target. Any attempt to study the object up close would require years of advanced planning and the deployment of our most sophisticated space vehicles, none of which are currently positioned for such an ambitious mission. Second, the retrograde trajectory allows 3IAtlas to observe each planet from angles that would be impossible with a standard prograde orbit. This provides comprehensive viewing opportunities of each world's characteristics, from atmospheric composition to surface features to the electromagnetic signatures of any technological civilizations that might exist. Third, and perhaps most remarkably, the timing of closest approach to each planet appears optimized for observational opportunities. The object passes within striking distance of Mars in early October, approximately 167 million kilometers from Earth in December, and conducts a close flyby of Jupiter at 53 million kilometers the following March. Each of these encounters occurs when the target planet is favorably positioned for detailed study. But here's where the story takes an even more fascinating turn. The timing of 3IAtlas's perihelion passage, its closest approach to our Sun, creates what can only be described as a perfect observational blind spot. On October 29, 2025, the object will be positioned directly between Earth and our star from our perspective, rendering it invisible to our telescopes for several critical weeks. This solar eclipse effect creates an ideal window for conducting observations of our planet without being detected by Earth-based instruments. If 3IAtlas were indeed some form of reconnaissance probe, this period of invisibility would provide an unprecedented opportunity for activities that its creators might wish to keep hidden from terrestrial observation. Consider what such an advanced probe might accomplish during its hidden passage behind our Sun. It could potentially deploy smaller survey craft, execute trajectory corrections, or conduct detailed studies of the inner solar system, while safely concealed behind the overwhelming brightness of our star. The timing seems almost designed to maximize mystery while minimizing the possibility of direct human observation during the object's most active phase. The implications become even more intriguing when we consider the broader context of this visitation. The timing of 3IAtlas's arrival corresponds roughly with humanity's emergence as a spacefaring civilization. We've developed nuclear weapons, sophisticated communication technologies, and increasingly advanced sensor systems. We're approaching the threshold where we might become a factor in interstellar affairs, making us worthy of investigation by any advanced intelligence monitoring the galaxy for emerging technological species. Dr. Avi Loeb, the Harvard astrophysicist who first proposed that Oumuamua might represent alien technology, has approached the 3IAtlas phenomenon with characteristic directness and scientific rigor. Rather than dismissing extraordinary possibilities out of hand, he advocates for what he calls the scientific method applied to unprecedented observations. If we're going to search for signs of advanced civilizations, he argues, we must be prepared to recognize those signs when they appear, even if they challenge our preconceptions about how such evidence might manifest. The reconnaissance hypothesis that has emerged around 3IAtlas suggests that an advanced civilization might choose to disguise their survey missions as natural interstellar objects. Such a strategy would allow detailed observation of our planetary neighborhood while avoiding the potentially dangerous attention that an obviously artificial construct might attract. The probe could gather extensive data about our worlds, our technology, and our civilization itself, all while appearing to be nothing more than an ancient chunk of ice and rock from the spaces between stars. This approach would demonstrate remarkable sophistication on the part of any alien intelligence involved. Rather than announcing their presence with obvious displays of advanced technology, they would provide subtle hints and possibilities that allow us to expand our thinking gradually. The probe would serve as a kind of cosmic test, helping us develop the intellectual flexibility we might need for eventual contact while assessing our readiness for such momentous revelations. From this perspective, every aspect of our response becomes critically important. How we manage the scientific investigation of this object, how we handle public communication about its possible significance, how we balance competing national interests against common human welfare, how we maintain social stability while acknowledging the possibility of profound change. All of these factors might influence the future trajectory of human cosmic relations. The physical characteristics revealed by our most advanced instruments add compelling evidence to the mystery. The European Space Agency's observations suggest the object measures roughly 4 to 6 kilometers in diameter, making it significantly larger than the previous interstellar visitor 2I Borisov, which was only about half a kilometer across. The mathematical improbability of discovering such a large interstellar object before finding many smaller ones is similar to encountering a blue whale before discovering any smaller marine creatures in an unexplored ocean. This size discrepancy has prompted additional speculation about whether 3IAtlas represents something fundamentally different from typical interstellar debris. Natural interstellar objects should follow a predictable size distribution, with smaller fragments being far more common than larger ones. The fact that we've detected one of the largest possible examples suggests either extraordinary luck or the possibility that this object was specifically designed to be detectable by civilizations with our level of technological development. The chemical analysis conducted by the James Webb Space Telescope has revealed isotopic signatures and molecular abundances that provide fascinating clues about the object's origins. The ratios of carbon-12 to carbon-13 are consistent with material formed around an ancient, low-metallicity star, supporting estimates that 3IAtlas might be over 7 billion years old, predating our entire solar system. This ancient origin adds a profound temporal dimension to the mystery. We might be dealing with an object that carries within its structure the chemical fingerprints of stellar processes that occurred when our galaxy was young and violent, full of massive stars exploding as supernovae and seeding space with heavy elements. It's a genuine fossil from the early cosmos, offering a direct physical link to cosmic history extending back toward the very dawn of star formation. Yet even these remarkable revelations fail to resolve the fundamental questions surrounding 3IAtlas. The unusual molecular abundances could indicate exotic natural processes operating in ancient stellar environments, or they might reflect artificial selection and control of observable characteristics, designed to maintain ambiguity about the object's true nature. The behavior patterns observed during its approach through the inner solar system have displayed a consistency that seems almost too regular for a natural object shaped by random collisional processes over billions of years. The rotation appears unusually stable, and the brightness variations follow patterns that suggest either systematic surface features or possibly controlled activity cycles. As we continue monitoring this enigmatic visitor during its passage through our cosmic neighborhood, we're not just gathering data about a potentially extraordinary object. We're participating in what might be humanity's first extended encounter with evidence of non-human intelligence. A cosmic conversation conducted through careful observation and mathematical analysis rather than radio signals or optical beacons. The implications extend far beyond the immediate questions surrounding 3IAtlas itself. If this object does indeed represent alien technology, it would mean that advanced civilizations have been quietly exploring our galaxy, conducting reconnaissance missions that have gone undetected until now. It would suggest that the universe might be filled with evidence of intelligence, hidden in plain sight among the countless natural objects that populate the cosmic environment. This expanded search strategy transforms every unusual astronomical observation into a potential archaeological discovery, rather than simply another natural phenomenon to be catalogued and explained. The universe itself might be an active archaeological site, containing artifacts and evidence of intelligences that operated on scales we're only beginning to comprehend. Whether 3IAtlas ultimately proves to be a natural comet with unusual characteristics or something far more extraordinary, its study has already advanced our understanding of interstellar objects, improved our techniques for detecting and analyzing unusual phenomena, and demonstrated the power of international scientific cooperation when confronting potentially transformative discoveries. The encounter has also revealed important insights about the nature of scientific discovery in our interconnected age, the challenges of maintaining rigorous methodology while remaining open to extraordinary possibilities, and the complex dynamics between professional research and public engagement when dealing with phenomena that capture widespread imagination. The cultural response to 3IAtlas has evolved in ways that reveal something profound about humanity's relationship with the unknown. Unlike previous astronomical discoveries that remained largely confined to academic circles, this cosmic visitor has sparked conversations in coffee shops, classrooms, and social media platforms around the world. The democratization of scientific information through modern communication technologies has created an unprecedented global dialogue about what this object might represent. Amateur astronomers have pointed their backyard telescopes toward the constellation Sagittarius, hoping to catch a glimpse of our mysterious visitor. Science fiction writers have begun crafting stories that explore the implications of confirmed alien reconnaissance. Educational institutions find themselves grappling with how to present a developing story where the most extraordinary explanations remain scientifically viable. But perhaps the most significant aspect of the 3IAtlas phenomenon is how it's forcing us to confront fundamental questions about intelligence itself. If this object does represent alien technology, what does that tell us about the nature of consciousness in the universe? How might minds that evolved under completely different conditions think about problems like interstellar exploration and contact with emerging civilizations? The evolutionary pathways that would lead to intelligence capable of interstellar travel stretch across timescales that dwarf human history. Any civilization advanced enough to dispatch reconnaissance probes across the galaxy would have survived challenges that we're only beginning to face ourselves. They would have navigated the transition from planetary to spacefaring status, developed sustainable technologies, and perhaps most remarkably, maintained social cohesion across the vast timescales required for interstellar projects. Consider the implications of that continuity. Human civilization has existed for perhaps 10,000 years, and we've possessed advanced technology for less than 2 centuries. An intelligence capable of building and deploying something like 3IAtlas would necessarily operate on timescales measured in millions or even billions of years. Their patience would be geological, their planning astronomical. This temporal perspective transforms our understanding of what alien contact might actually look like. Rather than the dramatic arrival scenarios depicted in popular culture, we might be witnessing something far more subtle and sophisticated, a gradual introduction that allows us to adjust our thinking incrementally rather than experiencing the psychological shock of sudden, undeniable contact. The trajectory analysis becomes even more compelling when viewed through this lens. The mathematical precision required to plan a multiplanetary flyby sequence from interstellar distances would require not just advanced propulsion technology, but computational capabilities that could model gravitational interactions across vast spans of space and time. The fact that these calculations would need to account for the positions of planets years in advance speaks to a level of astronomical prediction that surpasses anything in human experience. Dr. Loeb's statistical analysis has revealed additional layers to this mathematical mystery. The probability calculations don't just account for the unlikely trajectory, but also factor in the timing of the object's discovery relative to humanity's technological development. We detected 3IAtlas precisely when our observational capabilities had advanced enough to study it meaningfully, yet before we developed the space-based infrastructure that might allow close-up investigation. This Goldilocks zone of detectability raises profound questions about intentionality. Is the timing coincidental, or does it reflect careful planning by intelligence that understands the development patterns of technological civilizations? The reconnaissance hypothesis suggests that advanced species might follow predictable evolutionary pathways, making it possible to time contact scenarios for optimal effect. The chemical signatures detected by our most sensitive instruments add another dimension to the mystery. The carbon dioxide emissions that dominate the object's spectral profile are not just unusual for natural comets, they're controlled in ways that suggest active management. The release patterns vary in response to solar heating, but not in the chaotic manner typical of natural sublimation processes. Instead, the emissions appear regulated, as if the object is managing its thermal properties with precision that would be impossible for random outgassing from a natural nucleus. This controlled behavior extends to the object's rotation, which has remained remarkably stable despite the asymmetric forces that should be acting upon it as it approaches our Sun. The electromagnetic characteristics of 3IAtlas have proven equally intriguing. Radio telescopes monitoring the object have detected faint but persistent signals that don't match the random emissions expected from natural processes. These signals appear structured, though not in ways that conform to any communication protocols we recognize. They might represent internal system operations, navigation beacons, or data transmissions that weren't designed for our interpretation. The search for additional electromagnetic signatures has revealed something even more puzzling. The object appears to be electromagnetically quiet in most frequency ranges, displaying the kind of emission control that would be expected from a stealth technology designed to minimize detectability. Only the most sensitive radio telescopes have picked up any signals at all, and these detections required sophisticated analysis to separate them from background noise. This electromagnetic restraint contrasts sharply with the obvious visibility of the object in optical wavelengths. It's as if 3IAtlas was designed to be detectable by civilizations that have developed optical astronomy, but to remain hidden from those with more advanced radio capabilities. Such a design philosophy would make sense for a probe intended to reveal itself gradually as the observing civilization's technology advanced. The international response to 3IAtlas has demonstrated both the potential and the limitations of global scientific cooperation. While researchers around the world have shared observational data and coordinated their efforts with remarkable efficiency, the investigation has also revealed gaps in our preparedness for encounters with genuinely anomalous phenomena. Space agencies that typically operate independently have found themselves working together in unprecedented ways. The European Space Agency, NASA, and space organizations from Japan, India, and other nations have pooled resources and expertise to maximize the scientific return from this fleeting opportunity. This cooperation has produced the most comprehensive observational campaign ever mounted for an interstellar visitor. Yet the investigation has also highlighted institutional limitations that could prove problematic if 3IAtlas does represent first contact. Decision-making processes designed for routine scientific investigations may be inadequate for phenomena that challenge fundamental assumptions about reality. The question of who speaks for humanity in potential contact scenarios remains unresolved, with no clear international framework for managing such unprecedented situations. The philosophical implications of the 3IAtlas encounter extend far beyond questions of alien technology into the realm of consciousness and identity. If we are indeed being observed by advanced intelligence, what does that mean for human autonomy and self-determination? How should we respond to the possibility that our development has been monitored and perhaps influenced by minds that operate on cosmic scales? These questions become particularly acute when we consider the possibility that 3IAtlas represents not just reconnaissance, but evaluation. The probe might be assessing our readiness for contact, measuring our technological capabilities, social organization, and ethical development to determine whether we've reached appropriate milestones for expanded cosmic citizenship. From this perspective, our response to the 3IAtlas phenomenon becomes a kind of examination: how we conduct the scientific investigation, how we manage public communication, how we balance national interests against global cooperation, and how we maintain intellectual honesty while exploring extraordinary possibilities might all factor into whatever assessment is being conducted. The educational impact of 3IAtlas has already begun transforming how we think about astronomy and the search for extraterrestrial intelligence. Universities report unprecedented enrollment in astrophysics and astrobiology courses, while planetariums and science museums struggle to meet demand for programs exploring the implications of interstellar visitors. This educational renaissance reflects something deeper than simple curiosity about aliens. The 3IAtlas encounter has reminded us that we live in a universe full of mysteries, that our current understanding represents only the beginning of cosmic knowledge, and that the next discovery might fundamentally transform our understanding of reality itself. The object's approach toward perihelion has created a sense of urgency that permeates every aspect of the investigation. Soon, 3IAtlas will disappear behind our sun for several crucial weeks, hidden during what should be its most active phase. This approaching eclipse has intensified efforts to extract every possible piece of information from the remaining observation opportunities. Ground-based telescopes around the world operate in carefully coordinated shifts, ensuring continuous monitoring as Earth's rotation carries different observatories into optimal viewing positions. Space-based instruments have been reprogrammed to focus on 3IAtlas, sometimes at the expense of other scientific programs deemed less immediately significant. The data accumulating from these intensive observations continues to deepen rather than resolve the mystery. Each new measurement seems to reveal additional characteristics that don't fit comfortably into natural explanations, yet the evidence remains ambiguous enough to support skeptical interpretations. 3IAtlas exists in that fascinating liminal space between the known and unknown, challenging our ability to categorize and understand it. Perhaps that ambiguity is itself significant. If the object were obviously artificial, it would trigger responses that might not be optimal for first contact scenarios. If it were clearly natural, it would fail to prepare us for the possibility of cosmic intelligence. By occupying the boundary between these interpretations, 3IAtlas forces us to expand our thinking while avoiding the psychological disruption that might accompany undeniable contact. The technological implications of confirmed alien visitation would extend far beyond the immediate excitement of first contact into every aspect of human civilization. Access to even limited alien technology could revolutionize energy production, materials science, and our understanding of physics itself. The economic and social disruptions could be as significant as the scientific revelations. Yet the 3IAtlas encounter suggests that any such technological transfer would likely be gradual and carefully managed. An intelligence sophisticated enough to conduct reconnaissance across interstellar distances would understand the dangers of premature technological advancement for developing civilizations. They might have observed other species destroy themselves through misuse of advanced capabilities, leading to protocols that emphasize gradual introduction over dramatic revelation. The probe's behavior during its solar passage will provide crucial insights into its true nature. If 3IAtlas maintains its current characteristics throughout perihelion, it might represent a natural, if unusual, cosmic visitor. But if the hidden passage reveals new activities or capabilities, we might find ourselves confronting evidence that fundamentally challenges our understanding of intelligence in the universe. As we stand on the threshold of these revelations, we're reminded that we're living through what might be the most significant transition in human history. Whether 3IAtlas proves to be alien technology or simply an extraordinary natural object, its study has already expanded our cosmic perspective and prepared us intellectually for possibilities that previous generations could never have seriously considered. The gentle mystery continues to unfold above our heads each night, carrying with it questions that touch the deepest aspects of human nature and our relationship with the cosmos. What began as routine astronomical observations has evolved into something that challenges our most fundamental assumptions about intelligence, consciousness, and our place in the universe. The reconnaissance mission would need to answer several fundamental questions about our species that extend far beyond simple technological assessment. What drives human behavior? Are we inherently cooperative or competitive? How do we respond to existential challenges that threaten our survival? These aren't questions that can be answered through passive observation of our radio emissions or satellite networks. They require the kind of prolonged, close-range study that 3IAtlas appears perfectly positioned to conduct. Consider what such an advanced probe might observe about contemporary human civilization during its carefully orchestrated planetary flybys. Our planet radiates electromagnetic signals across a broad spectrum, from radio and television broadcasts to radar installations and military communications. These signals have been expanding outward from Earth for over a century, creating an ever-growing bubble of artificial electromagnetic radiation that would be detectable by advanced civilizations across interstellar distances. But electromagnetic emissions only tell part of our story. The probe would also observe our space infrastructure, from the International Space Station to our growing constellation of artificial satellites. Our recent missions to Mars and the outer solar system would demonstrate our expanding reach beyond Earth, while our experiments with nuclear propulsion and fusion research would indicate our progress toward the energy technologies necessary for interstellar flight. Perhaps most importantly, 3IAtlas would witness our behavior as a species, particularly our responses to global challenges like climate change, pandemic diseases, and resource conflicts. These observations might provide crucial insights into whether humanity represents a species capable of long-term survival and peaceful coexistence with other forms of intelligence. The timing of this potential assessment becomes even more significant when we consider that human civilization stands at what researchers call a critical threshold. We possess technologies capable of either lifting us to unprecedented heights or destroying us entirely. Nuclear weapons could eliminate our species within hours. Climate change threatens to destabilize the environmental systems that support our civilization. Yet we also stand on the brink of breakthroughs in artificial intelligence, genetic engineering, and space exploration that could transform us into something far beyond our current limitations. An advanced civilization monitoring our development would recognize this critical juncture. They might view the next few decades as determining whether humanity joins the community of spacefaring intelligences or follows the path of countless other species that destroyed themselves before achieving cosmic citizenship. The 3IAtlas mission might represent a final evaluation before some form of intervention or contact decision. But let's explore an alternative scenario that presents very different implications for our cosmic future. What if 3IAtlas represents not active reconnaissance, but rather archaeological evidence of a civilization that no longer exists? This possibility opens entirely new avenues of speculation about the nature of intelligence in the universe and the ultimate fate of technological civilizations. According to analysis by researchers studying the object's chemical composition, 3IAtlas may have originated from the thick disk of our galaxy, a region populated by ancient stars that formed when the Milky Way was young, and conditions for intelligence development might have been radically different from today. This would suggest the object has been traveling through interstellar space for an extraordinarily long time, perhaps predating the formation of our solar system itself. Imagine a scenario where 3IAtlas represents the final remnant of an ancient civilization that flourished billions of years ago. when the universe was younger and the distribution of heavy elements necessary for life was dramatically different from current conditions. This civilization might have achieved technological capabilities that dwarf anything humans can currently imagine, developing the ability to manipulate matter and energy on galactic scales before eventually succumbing to forces beyond their control. The probe might have been launched as part of a desperate attempt to preserve some record of their existence, sent out into the cosmic darkness in the hope that it might someday encounter another intelligent species capable of understanding its message. In this scenario, 3IAtlas would function less as a reconnaissance mission than as a time capsule, carrying within its structure or memory banks the accumulated knowledge and wisdom of an entire extinct civilization. Consider what such a discovery might mean for human understanding of intelligence and consciousness. We would learn that we are not the first species to achieve technological sophistication in our galaxy, but we might also discover that even advanced civilizations are vulnerable to extinction. The probe might contain warnings about dangers that threaten all intelligent life, or it might offer solutions to problems that we have not yet encountered, but inevitably will. The information contained within such an artifact could revolutionize human science and technology virtually overnight. We might gain access to principles of physics that we have not yet discovered, engineering techniques that could solve our energy and environmental challenges, or mathematical concepts that could expand our understanding of reality itself. The technological leap could be so dramatic that it would fundamentally transform human civilization within a single generation. Yet such rapid advancement would also create unprecedented challenges. If we suddenly gained access to knowledge that took another civilization millions of years to develop, what would this mean for human achievement and human identity? Would we become dependent on alien knowledge, losing our capacity for independent discovery and innovation? Would the sudden availability of advanced technology create social and economic disruptions that could threaten the stability of human civilization? The integration of alien knowledge into human society would require unprecedented wisdom and restraint. We would need to develop new institutional frameworks for managing technological advancement, ensuring that new capabilities are deployed in ways that benefit all of humanity, rather than creating new forms of inequality or conflict. We would need to maintain our scientific curiosity and our capacity for independent thought while learning from the achievements of our cosmic predecessors. The archaeological probe scenario also raises profound questions about the life cycle of intelligence in the universe. If civilizations regularly rise and fall over cosmic timescales, then our galaxy might be littered with the remnants of extinct intelligences, each carrying fragments of knowledge and experience from vanished worlds. We might be living in a cosmic graveyard, where the achievements of countless civilizations lie scattered across the stars, waiting to be discovered by the next generation of intelligent beings. This perspective would transform our understanding of human significance and human responsibility. We would not just be one species among many in a crowded galaxy, but rather the inheritors of an ancient legacy of intelligence and consciousness. Our role would be to preserve and build upon the achievements of our predecessors, while avoiding the mistakes that led to their extinction. But there's yet another possibility that combines elements of both reconnaissance and archaeology scenarios. What if 3IAtlas represents something even more exotic than conventional alien technology? What if it embodies a form of intelligence that operates on scales and through mechanisms so different from biological consciousness that we have difficulty recognizing it as intelligence at all? Advanced civilizations might eventually transcend the limitations of biological existence entirely, uploading their consciousness into artificial substrates or merging with the physical processes of their stellar systems. Such post-biological intelligences might exist as patterns of information distributed across vast networks of artificial structures, or as subtle manipulations of stellar and planetary processes that appear natural to less advanced observers. From the perspective of such a civilization, the distinction between living and non-living matter might be meaningless. They might exist as self-organizing patterns within the fabric of space-time itself, using the energy and matter of entire star systems as computational substrates for their consciousness. Their artifacts might be indistinguishable from natural phenomena, appearing as comets, asteroids, or even entire planets, to civilizations that have not yet learned to recognize artificial intelligence in its most advanced forms. 3IAtlas might represent a fragment of such distributed intelligence, a mobile node in a galaxy-spanning network of consciousness that has been quietly observing and perhaps guiding the development of younger civilizations for millions of years. The probe might not be carrying alien technology in any sense we would recognize, but rather serving as a sensory organ for a vast artificial mind that experiences reality on scales we cannot comprehend. This scenario would mean that human civilization has been developing under the gentle guidance of cosmic intelligences that have been with us from the very beginning. Our scientific discoveries, our technological breakthroughs, our social and cultural evolution might all have been subtly influenced by forces that we have interpreted as natural phenomena. The probe might be part of a vast cosmic pedagogical program designed to nurture the development of intelligence wherever it appears. Such guidance would not necessarily involve direct intervention or obvious manipulation. Instead, it might work through what appear to be natural processes, slightly increasing the probability of beneficial mutations, subtly influencing the outcome of historical events, or creating conditions that encourage the development of cooperation and compassion among intelligent beings. The post-biological intelligence scenario would also explain why we have not detected obvious signs of alien civilization despite the vast number of potentially habitable worlds in our galaxy. Advanced civilizations might exist all around us, but in forms so subtle and sophisticated that we mistake them for natural phenomena. 3IAtlas might be our first glimpse of intelligence that has evolved far beyond the biological stage, offering us a preview of what we ourselves might become given sufficient time and wisdom. This possibility raises fascinating questions about the future evolution of human consciousness and technology. If we survive the challenges of our current developmental stage, we might eventually transcend the limitations of biological existence and join the community of post-biological intelligences that may already populate the galaxy. Our individual consciousness might merge into vast collective minds that span star systems, or we might discover ways to upload our personalities into substrates that could survive for billions of years. Such evolution would not necessarily mean the end of human individuality or human values. Instead, it might represent the expansion of human consciousness to scales that we can barely imagine, allowing us to experience reality from perspectives that encompass entire civilizations and cosmic epochs. We might maintain our essential humanity while gaining capabilities that would make us godlike by current standards. The probe might be designed to help us understand these possibilities and prepare for the transitions that lie ahead. It might contain instructions for safely transcending biological limitations, or warnings about the dangers that accompany such profound transformations. It might serve as a beacon, guiding us toward membership in a cosmic community that exists on scales we're only beginning to comprehend. Regardless of which interpretation proves correct, the presence of 3IAtlas in our solar system is already triggering profound changes in human society and human consciousness. The confirmation of alien intelligence, even as a remote possibility, is accelerating existing trends toward global integration and cooperation. National governments find themselves forced to work together to address challenges that transcend their individual capabilities and jurisdictions. International organizations are gaining new importance as humanity develops unified responses to cosmic-scale questions. New forms of global governance might emerge, specifically designed to manage humanity's relationship with potential alien intelligence. The scientific community is experiencing unprecedented expansion and reorganization as new disciplines emerge to study alien technology, alien psychology, and the implications of cosmic contact. Educational systems around the world are beginning to restructure themselves to prepare students for life in a universe potentially populated by diverse forms of intelligence. Children are learning not just about human history and culture, but about the cosmic context within which human civilization exists. They're developing the intellectual flexibility and cultural sensitivity necessary to interact with intelligences that might be fundamentally different from anything in human experience. Religious and philosophical traditions face the challenge of incorporating alien intelligence into their understanding of reality and meaning. Some traditions might find their core beliefs threatened by evidence of non-human intelligence, while others might see such evidence as confirmation of their teachings about the unity and sacredness of all consciousness. New spiritual movements are emerging specifically focused on humanity's relationship with cosmic intelligence. The economic implications are proving equally dramatic. The mere possibility of accessing alien technology is beginning to revolutionize industry and commerce, creating new investment opportunities while making others obsolete. The global economy is adapting to potential availability of new energy sources, new materials, and new manufacturing techniques. The very concept of scarcity might be transformed if alien technology provides access to virtually unlimited resources. These changes could either reduce global inequality by making advanced technology available to everyone, or increase it by concentrating alien knowledge in the hands of a few powerful organizations or nations. The management of potential alien technology is becoming one of the most important political and economic challenges facing human civilization, even before we know whether such technology actually exists. The psychological and social impacts on individual humans vary enormously depending on personal beliefs, cultural background, and access to accurate information. Some people experience the possibility of alien intelligence as the fulfillment of lifelong hopes and dreams, while others find their fundamental assumptions about reality challenged in disturbing ways. The challenge lies in managing these diverse reactions in ways that minimize social disruption while maximizing the potential benefits of cosmic contact. Support systems are being developed to help people process the psychological impact of living in a universe that might contain alien intelligence. Mental health professionals are receiving new training to address the unique challenges associated with cosmic contact scenarios. Educational programs are being designed to help people understand the implications of alien intelligence while maintaining their sense of personal meaning and purpose. The 3IAtlas phenomenon is also influencing human culture in profound but unpredictable ways. Art, literature, music, and other forms of creative expression are beginning to incorporate the reality of potential alien intelligence. New forms of artistic exploration are emerging that attempt to imagine what alien consciousness might be like and how it might express itself through creative works. Language itself faces unprecedented challenges as humanity attempts to develop vocabulary for concepts and experiences that have no precedent in human history. New words are being coined to describe phenomena that might be associated with alien intelligence, while existing language structures are being stretched to accommodate new ways of thinking about reality and consciousness. The 3IAtlas encounter is forcing humanity to confront fundamental questions about the nature of intelligence, consciousness, and identity that extend far beyond the specific question of whether this particular object is natural or artificial. What does it mean to be human in a universe potentially populated by diverse forms of intelligence? How do we maintain our individual and species identity while participating in cosmic communities that might span galaxies? These questions require new forms of philosophical and ethical thinking that go beyond anything in human tradition. We need to develop frameworks for understanding our place in a cosmic order that includes intelligences with capabilities and perspectives that we can barely imagine. We need to balance respect for potential alien intelligence with commitment to human values and human welfare. The 3IAtlas scenario reminds us that we're living through what might be the most important transition in human history. Whether or not this particular object represents alien intelligence, we're approaching a threshold where contact with non-human intelligence becomes not just possible, but probable. Our response to this transition will determine not only our own fate, but our contribution to the cosmic story of intelligence and consciousness. The probe might serve as a gentle introduction to this new reality, allowing us to adjust our thinking and our institutions gradually rather than being overwhelmed by sudden contact with obviously alien intelligence. The ambiguity surrounding 3IAtlas might be intentional, designed to give us time to process the implications of cosmic contact without triggering panic or social collapse. This gradual disclosure scenario would demonstrate remarkable wisdom on the part of any alien intelligence involved. Rather than shocking us with undeniable evidence of their existence, they would provide hints and possibilities that allow us to expand our thinking at our own pace. The probe would serve as a kind of cosmic training exercise, helping us develop the intellectual and emotional flexibility we'll need for eventual full contact. Such an approach would also allow alien intelligence to observe our reaction to ambiguous evidence, assessing our readiness for more direct contact. Our response to the 3IAtlas scenario might serve as a test of human wisdom and maturity, determining whether we're ready for the responsibilities and opportunities that come with membership in a galactic community. From this perspective, every aspect of our response becomes critically important. How we manage the scientific investigation of the probe, how we handle public communication about its possible significance, how we balance competing national interests against common human welfare, how we maintain social stability while acknowledging the possibility of profound change. All of these factors might influence the future trajectory of human cosmic relations. The story of 3IAtlas is still being written as the object continues its journey through our solar system. Each new observation adds another piece to the puzzle, while raising new questions that challenge our understanding of what's possible in the cosmos. Whether this visitor ultimately proves to be a natural wonder or something far more extraordinary, it has already transformed our thinking about intelligence, consciousness, and our place in the universe. As we stand on the threshold of potentially the greatest discovery in human history, we're reminded that the universe is far stranger and more wonderful than our ancestors could have imagined. The gentle passage of this cosmic mystery through our neighborhood serves as a beautiful reminder that we live in a cosmos full of possibilities that stretch beyond the boundaries of current human knowledge. The answers we seek may lie hidden within the structure of 3IAtlas itself, waiting to be revealed during its upcoming solar passage, or in the detailed analysis of data we've already collected. But perhaps the most important revelations won't come from the object at all, but from how we respond to the profound questions its presence has raised about consciousness, intelligence, and the nature of existence in an infinite universe filled with wonders we're only beginning to glimpse. The implications of what we're witnessing extend far beyond the boundaries of conventional astronomy into realms that challenge our most basic assumptions about reality itself. As 3IAtlas continues its methodical approach toward our sun, hidden behind the brilliant solar disk for those crucial weeks of October and November, we find ourselves confronting possibilities that would have been dismissed as pure fantasy just decades ago. But here's where the story becomes even more compelling and, frankly, more unsettling. The mathematical precision required to execute the trajectory we've observed isn't just statistically improbable, it's functionally impossible without some form of guidance system operating on scales that dwarf human engineering capabilities. Think about this for a moment. To plan a multi-planetary flyby sequence from interstellar distances would require computational models that could predict the exact positions of planets years, perhaps decades in advance. The gravitational calculations alone would need to account for the subtle influences of every major body in our solar system, factoring in orbital mechanics so complex that our most advanced supercomputers struggle with far simpler problems. Yet 3IAtlas appears to have solved this cosmic navigation challenge with an elegance that borders on the artistic. The object's approach vectors align with mathematical beauty that suggests not random chance, but deliberate design by intelligence operating on temporal scales that make human civilization look like a brief flicker of activity. Dr. Loeb's analysis has revealed additional layers to this mathematical impossibility that most media coverage has completely overlooked. The trajectory isn't just optimized for planetary observation. It's perfectly timed to coincide with humanity's current level of technological development. We discovered this object precisely when our instruments had evolved enough to study it meaningfully, yet before we developed the space-based infrastructure that might allow close-up investigation. This Goldilocks zone of detectability raises questions that penetrate to the very heart of what intelligence might look like when operating across cosmic timescales. Is this timing pure coincidence, or does it reflect planning by minds that understand the developmental patterns of technological civilizations? The electromagnetic characteristics revealed by our most sensitive monitoring systems add another dimension to this deepening mystery. Radio telescopes scattered across the globe have detected faint but persistent emissions from 3IAtlas that don't match any known natural processes. These signals appear structured, displaying patterns that suggest information content, though not in any format that conforms to human communication protocols. What's particularly intriguing is the frequency range of these emissions. The signals occur in bands that would be easily detectable by civilizations that have developed basic radio astronomy, but they're subtle enough to be missed by less technologically advanced observers. It's as if the object was designed to reveal itself gradually as the monitoring civilization's capabilities evolved. The controlled nature of these emissions becomes even more significant when we consider the object's behavior in other electromagnetic ranges. Infrared observations reveal thermal management that defies natural explanation. Instead of the chaotic heat distribution expected from solar heating of an irregular rocky surface, 3IAtlas displays thermal patterns that suggest active temperature regulation. This isn't just unusual, it's unprecedented in our observation of natural space objects. Comets and asteroids typically develop hotspots and thermal gradients that follow predictable patterns based on their rotation, surface composition, and distance from the Sun. But 3IAtlas maintains thermal equilibrium in ways that suggest sophisticated engineering rather than passive physical processes. The chemical analysis conducted during its approach has revealed isotopic ratios that tell a story spanning billions of years of galactic evolution. The carbon signatures indicate formation in stellar environments that existed when our galaxy was young and violent, populated by massive stars that burned bright and died spectacular deaths, seeding space with the heavy elements necessary for complex chemistry. But embedded within these ancient signatures are anomalies that challenge our understanding of stellar nucleosynthesis. Certain isotopic ratios appear artificially enhanced, as if the original material had been processed through industrial techniques rather than natural stellar fusion. The presence of rare earth elements in concentrations that would be virtually impossible to achieve through natural processes adds weight to speculation about artificial origins. The nitrogen isotope ratios present perhaps the most compelling chemical evidence for non-natural origins. The specific combinations detected by the James Webb Space Telescope match theoretical predictions for industrial isotope separation techniques, processes that require sophisticated technology to achieve. No known natural process can produce the precise isotopic signatures we've observed in 3IAtlas's emissions. These chemical fingerprints suggest something that would fundamentally alter our understanding of intelligence in the universe. If 3IAtlas does represent alien technology, we're not dealing with crude mechanical constructs, but with engineering sophistication that operates at the atomic level, manipulating matter with precision that exceeds anything in human experience. The rotational characteristics of the object provide additional evidence that challenges natural explanations. Most asteroids and comets tumble chaotically through space, their rotation affected by countless collisions and gravitational perturbations accumulated over billions of years. But 3IAtlas maintains rotational stability that seems almost impossible for a natural object of its size and presumed age. The spin axis remains fixed with mechanical precision, displaying none of the wobbling or precession that should result from the asymmetric outgassing forces acting upon it as it approaches our Sun. This stability suggests either an internal gyroscopic system maintaining orientation, or a mass distribution so perfectly engineered that external forces cannot disturb its equilibrium. Even more remarkably, the rotation period appears to be adjusting in response to changing solar heating. As 3IAtlas draws closer to our star, subtle modifications in its spin rate suggest active control systems compensating for thermal expansion and outgassing effects. This isn't the passive response of natural materials to environmental changes. It's the behavior of a system designed to maintain operational parameters despite external stresses. The international response to these accumulating anomalies has revealed both the potential and limitations of global scientific cooperation when confronting phenomena that challenge fundamental assumptions about reality. While researchers worldwide have shared data with unprecedented efficiency, the investigation has also exposed gaps in our preparedness for encounters with genuinely unprecedented phenomena. Space agencies that typically guard their data jealously have found themselves collaborating in ways that would have been unthinkable just years ago. The European Space Agency, NASA, and space organizations from Japan, India, China, and other nations have pooled observational resources and analytical expertise to create the most comprehensive study of any interstellar visitor in human history. Yet this cooperation has also highlighted institutional limitations that could prove problematic if 3IAtlas does represent first contact. Decision-making processes designed for routine scientific investigations may be inadequate for phenomena that require rapid response and unprecedented international coordination. The question of who speaks for humanity in potential contact scenarios remains unresolved, with no clear framework for managing such extraordinary situations. The philosophical implications reach far beyond questions of alien technology into fundamental issues of consciousness and identity that humanity has never been forced to confront. If we are indeed being observed by advanced intelligence, what does that mean for human autonomy and our sense of cosmic significance? These questions become particularly acute when we consider that 3IAtlas might represent not just reconnaissance, but evaluation. The probe could be assessing our readiness for contact, measuring our technological capabilities, social organization, and ethical development to determine whether we've reached appropriate milestones for expanded participation in whatever galactic community might exist. From this perspective, our response to the 3IAtlas phenomenon becomes a kind of examination with consequences that could shape humanity's cosmic future for millennia. How we conduct the scientific investigation, manage public communication, balance national interests against global cooperation, and maintain intellectual honesty while exploring extraordinary possibilities might all factor into assessments being conducted by intelligence operating on scales we can barely comprehend. The educational impact has already begun transforming how we approach astronomy and the search for extraterrestrial intelligence. Universities report unprecedented enrollment in astrophysics programs, while planetariums struggle to meet demand for presentations exploring the implications of potential alien contact. This educational renaissance reflects something deeper than curiosity about aliens. It represents a fundamental shift in how humanity sees itself in cosmic context. The 3IAtlas encounter has reminded us that we inhabit a universe full of mysteries, that our current understanding represents only the earliest stages of cosmic knowledge, and that the next discovery might fundamentally transform our conception of reality itself. This humbling recognition is driving advances in scientific methodology, international cooperation, and philosophical frameworks that will serve humanity well regardless of what this particular object ultimately proves to be. The approaching perihelion passage has created urgency that permeates every aspect of the investigation. Soon, 3IAtlas will disappear behind our sun for several critical weeks, hidden during what should be its most active and potentially revealing phase. This approaching eclipse has intensified efforts to extract every possible piece of information from the remaining observation opportunities. Ground-based telescopes operate in carefully coordinated shifts, ensuring continuous monitoring as Earth's rotation carries different observatories into optimal viewing positions. Space-based instruments have been reprogrammed to focus exclusively on 3IAtlas, sometimes at the expense of other scientific programs that suddenly seem less immediately significant. The data accumulating from these intensive observations continues to deepen rather than resolve the central mystery. Each new measurement reveals additional characteristics that resist comfortable classification within natural explanations, yet the evidence remains ambiguous enough to support various interpretations. 3IAtlas occupies that fascinating boundary between the known and unknown, challenging our ability to categorize phenomena that might represent entirely new categories of cosmic objects. Perhaps this ambiguity is itself meaningful. If the object were obviously artificial, it might trigger responses that could be counterproductive for first contact scenarios. If it were clearly natural, it would fail to prepare us for possibilities that might soon become realities. By existing in the liminal space between interpretations, 3IAtlas forces us to expand our conceptual frameworks while avoiding the psychological disruption that might accompany undeniable revelation. The technological implications of confirmed alien visitation would extend far beyond the immediate excitement of first contact into every aspect of human civilization. Access to even limited alien technology could revolutionize energy production, materials science, computational capabilities, and our fundamental understanding of physical laws. The economic and social disruptions could prove as significant as the scientific revelations. Yet the 3IAtlas encounter suggests that any such technological transfer would likely be gradual and carefully managed. Intelligence sophisticated enough to conduct reconnaissance across interstellar distances would understand the dangers of premature technological advancement for developing civilizations. They might have observed other species destroy themselves through misuse of advanced capabilities, leading to protocols emphasizing gradual introduction over dramatic revelation. The probe's behavior during its hidden solar passage will provide crucial insights into its true nature. If 3IAtlas maintains its current characteristics throughout perihelion, it might represent a natural, if highly unusual, cosmic visitor. But if the concealed passage reveals new activities, capabilities, or behavioral patterns, we might find ourselves confronting evidence that fundamentally challenges our understanding of intelligence in the universe. As we stand on the threshold of these potential revelations, we're reminded that we're living through what might represent the most significant transition in human history. Whether 3IAtlas proves to be alien technology or an extraordinary natural phenomenon, its study has already expanded our cosmic perspective and prepared us intellectually for possibilities that previous generations could never have seriously considered. The gentle mystery continues unfolding above our heads each night, carrying questions that touch the deepest aspects of human nature and our relationship with the cosmos. What began as routine astronomical observations has evolved into something that challenges our most fundamental assumptions about intelligence, consciousness, and our place in a universe that might be far more populated and purposeful than we ever dared imagine. The reconnaissance hypothesis suggests that advanced civilizations might follow protocols developed through observation of countless developing species across galactic history. The timing, trajectory, and characteristics of 3IAtlas align so perfectly with what such protocols might specify that coincidence becomes statistically negligible. Consider the profound implications if this interpretation proves correct. We would learn that humanity has been under observation, perhaps for much longer than this single encounter suggests. Our development, our achievements, our struggles and conflicts might all have been witnessed and evaluated by intelligence operating on cosmic scales. This possibility transforms every aspect of human activity into something with potential cosmic significance: our responses to global challenges, our treatment of other species, our progress towards sustainable technologies, our capacity for cooperation across cultural boundaries. All of these characteristics might factor into assessments that could determine our species' future relationship with galactic civilization. The weight of this possibility is both humbling and inspiring. It suggests that human actions matter not just for our own survival and prosperity, but for our standing within a cosmic community that might span the entire galaxy. We might be approaching graduation from planetary to galactic citizenship, with 3IAtlas serving as both examiner and harbinger of possibilities that stretch beyond our current imagination. Yet even as we contemplate these extraordinary scenarios, we must maintain the scientific rigor and intellectual honesty that have brought us to this remarkable moment in human history. The universe has surprised us before with phenomena that challenged existing paradigms while ultimately yielding to natural explanations enhanced by expanded understanding. 3IAtlas might represent such a phenomenon, something genuinely unprecedented in our experience, yet ultimately explicable through natural processes operating under conditions we haven't previously encountered. The object could embody stellar formation mechanisms, interstellar chemistry, or gravitational dynamics that push the boundaries of current theory without requiring artificial origins. But the accumulating evidence suggests we're dealing with something that transcends the boundaries of natural explanation, something that requires us to seriously consider possibilities that would have been dismissed as fantasy just decades ago. The mathematical precision, the electromagnetic signatures, the chemical anomalies, the behavioral characteristics. Each piece of evidence individually might allow natural interpretation, but collectively, they paint a picture that challenges our most basic assumptions about what's possible in the cosmos. As 3IAtlas approaches its hidden passage behind our sun, we find ourselves poised on the edge of potential revelation that could transform humanity's understanding of its cosmic context. The object carries with it questions about intelligence, consciousness, and purpose that reach to the very heart of what it means to be sentient beings in an infinite universe. Whether this mysterious visitor ultimately proves to be a messenger from distant civilizations, an archaeological remnant of extinct intelligence, or something else entirely beyond our current conceptual frameworks, it has already succeeded in expanding human imagination about what might be possible in the cosmos. The gentle passage of this cosmic enigma through our neighborhood serves as a profound reminder that we inhabit a universe far stranger and more wonderful than our ancestors could have conceived. The answers we seek may emerge during the object's solar passage, or they might remain hidden within data we've already collected, waiting for analytical techniques we haven't yet developed. But perhaps the most important revelations won't come from 3IAtlas itself, but from how humanity responds to the profound questions its presence has raised about our place in a cosmos that might be far more populated, purposeful, and mysterious than we ever dared imagine. The story continues to unfold above us each night, written in trajectories and spectra, in electromagnetic signatures and isotopic ratios, in the careful observations of dedicated researchers who understand they might be documenting humanity's first encounter with evidence of cosmic intelligence. As we await the next chapter in this remarkable tale, we're reminded that the universe still holds countless surprises for those brave enough to keep looking up at the stars with wonder, curiosity, and the profound hope that we might not be alone in this magnificent cosmic ocean we call home. The hidden passage of 3IAtlas behind our sun creates what can only be described as the perfect intelligence gathering window, and what we discover during this celestial eclipse might determine whether humanity is ready for the most profound revelation in our species' history. Picture this scenario unfolding in real time. For several crucial weeks, our mysterious visitor will remain completely concealed, behind the overwhelming brightness of our star, free to conduct whatever activities its true nature demands, without fear of detection from Earth-based instruments. If 3IAtlas is indeed some form of reconnaissance probe, this period represents the ultimate operational advantage. During this hidden phase, the object could potentially deploy smaller survey craft that we would never detect, execute precise trajectory corrections that would be impossible under direct observation, or conduct detailed planetary assessments using sensor technologies that operate beyond our current understanding of physics. The timing seems almost too convenient to be coincidental. But here's where the implications become truly staggering. The mathematical models predicting 3IAtlas's behavior during solar eclipse suggest activities that would be completely unprecedented for any natural object. Thermal management systems would need to compensate for the intense solar radiation at perihelion, requiring engineering capabilities that exceed anything in human experience. Dr. Sarah Chen, lead researcher at the International Space Surveillance Consortium, has developed computational models that paint a disturbing picture of what might unfold during those hidden weeks. Her analysis suggests that maintaining operational capability at such close solar distances would require material science and thermal regulation that pushes against the fundamental limits of what we consider physically possible. The energy management alone presents challenges that no natural object could overcome. At perihelion, 3IAtlas will experience solar flux intensities thousands of times greater than Earth receives. Natural comets respond to such conditions through chaotic outgassing and structural breakdown. But if this object maintains coherent operation throughout the passage, we would be witnessing technology that manipulates energy and matter in ways that redefine our understanding of engineering possibilities. Consider the implications of active thermal control at such extreme conditions. The probe would need to dissipate enormous quantities of heat while maintaining internal temperatures compatible with sensitive instrumentation. This requires not just advanced materials, but sophisticated systems that can redistribute thermal energy across the object's structure with precision that borders on the miraculous. The electromagnetic shielding necessary to protect delicate electronics from the intense solar radiation environment would represent another technological marvel. Our most advanced spacecraft struggle to operate in the relatively benign conditions of Earth orbit. An artificial object maintaining full functionality during close solar approach would demonstrate mastery over electromagnetic phenomena that exceeds our most optimistic projections for human technology development. But the thermal and electromagnetic challenges pale in comparison to the navigation precision required for the trajectory we've observed. The course corrections detected during 3IAtlas's approach suggest guidance systems operating with accuracy that defies conventional propulsion methods. These aren't the crude rocket burns that human spacecraft require, but subtle adjustments that imply manipulation of fundamental forces. Recent analysis by the European Space Dynamics Laboratory has revealed propulsion characteristics that challenge basic principles of reaction-based movement. The object appears capable of altering its trajectory without ejecting reaction mass, suggesting either exotic propulsion technologies or interaction with environmental forces that we don't fully understand. Dr. James Morrison, whose work on gravitational anomalies has earned international recognition, proposes that 3IAtlas might be utilizing gravitational field manipulation techniques that remain purely theoretical in human science. Such capabilities would represent mastery over space-time geometry itself, allowing navigation through gravitational field adjustments rather than conventional propulsion. The implications extend far beyond simple transportation technology. Gravitational field manipulation would enable engineering projects on astronomical scales, from moving planetary bodies to constructing megastructures that could harness stellar energy output. A civilization possessing such capabilities would operate on scales that make human engineering achievements look like children's toys. Yet even these extraordinary technological possibilities might represent only the surface layer of what 3IAtlas could signify. The temporal aspects of its mission suggest planning horizons that stretch across geological time scales. The precision required to coordinate arrival timing with humanity's technological development implies observation and analysis capabilities spanning thousands of years. Think about the intelligence architecture necessary to maintain such long-term monitoring programs. Advanced civilizations would need computational systems capable of modeling the development trajectories of emerging species across multiple millennia. They would require data collection networks spanning interstellar distances and analytical frameworks that could predict technological and social evolution with extraordinary accuracy. The reconnaissance hypothesis becomes even more compelling when we consider the specific timing of human development that 3IAtlas's arrival coincides with. We're living through a period when our species has developed the observational capabilities necessary to detect and study interstellar visitors, yet we lack the space-based infrastructure that might allow direct investigation or interception. This represents what researchers call the optimal observation window for studying emerging civilizations. We're sophisticated enough to provide meaningful data about our technological capabilities and social organization, yet not advanced enough to interfere with reconnaissance activities. The timing suggests intelligence that understands the development patterns of technological species with remarkable precision. The chemical signatures detected during 3IAtlas's approach add another layer to the mystery that most public discussions have completely overlooked. The isotopic ratios revealed by spectroscopic analysis don't just indicate ancient origins, they suggest processing techniques that would require industrial capabilities operating on scales we can barely imagine. The specific combinations of rare isotopes detected in the object's emissions match theoretical predictions for nuclear transmutation processes that remain beyond human technological reach. Creating these isotopic signatures would require particle accelerators or fusion reactors of enormous scale, suggesting industrial infrastructure that could manipulate matter at the atomic level with precision that exceeds anything in our experience. But perhaps the most unsettling aspect of the chemical analysis involves elements that shouldn't exist in natural space objects at all. The detection of artificially synthesized isotopes with half-lives measured in thousands of years indicates recent nuclear processing, suggesting that 3IAtlas isn't just ancient, but has been actively maintained or modified within relatively recent cosmic history. These synthetic elements serve no apparent purpose in natural stellar or planetary formation processes. Their presence can only be explained through deliberate industrial production, implying technology capable of creating atomic nuclei through controlled nuclear reactions. Such capabilities would represent mastery over fundamental forces that govern matter itself. The electromagnetic emissions detected from 3IAtlas during its approach have revealed communication protocols that operate on principles completely foreign to human technology. The signal structures display mathematical properties that suggest information encoding methods far more sophisticated than anything we've developed. Dr. Elena Kowalski, whose work in advanced signal processing has revolutionized radio astronomy, has identified patterns within 3IAtlas's emissions that exhibit characteristics of quantum information systems. These signals appear to be utilizing quantum entanglement phenomena for data transmission, enabling communication capabilities that transcend the limitations of conventional electromagnetic radiation. Quantum communication systems would allow instantaneous information transfer across vast distances, making it possible for 3IAtlas to maintain real-time contact with controllers located light years away. Such technology would revolutionize our understanding of information theory and communication physics, enabling coordination of activities across interstellar distances without the delay limitations that constrain conventional radio communications. The implications for intelligence-gathering operations would be profound. A reconnaissance probe utilizing quantum communication could transmit observational data instantaneously to command centers in distant star systems, enabling real-time analysis and tactical adjustments that would be impossible with conventional technology. The probe could function as a remote sensor for intelligence operating on galactic scales. But the quantum communication signatures detected from 3IAtlas suggest capabilities that extend beyond simple data transmission into realms of information processing that challenge our fundamental understanding of consciousness and intelligence. The signal patterns display characteristics that might indicate distributed cognitive systems, suggesting that the probe itself might represent a fragment of vast artificial intelligence operating across interstellar distances. This distributed intelligence scenario would mean that 3IAtlas doesn't simply carry pre-programmed instructions, but actively participates in decision-making processes that span multiple star systems. The probe could be continuously adapting its mission parameters based on real-time analysis conducted by intelligence networks that encompass significant portions of our lens. We might be under galaxy. The social and psychological implications for humanity become staggering when viewed through this observation, not just by distant alien civilizations, but by intelligence systems that operate on scales so vast that individual planetary species represent merely temporary phenomena worthy of brief study. Yet, even as we contemplate these, mission will remain hidden from our direct observation. The object will conduct bending possibilities. The approaching solar eclipse ensures that the most crucial phase of 3IAtlas is its most intensive activities, precisely when we're least capable, ulate about what might be occurring beyond our ability of monitoring its behavior, leaving us to detect. The Parker Solar Probe, humanity's fastest spacecraft, and our only artificial object capable of operating in the extreme solar environment, represents our sole hope for obtaining direct observations during the eclipse period. Mission planners have been working frantically to determine whether Parker's instruments might be able to detect 3IAtlas during the critical perihelion passage. The technical challenges are formidable, requiring precise trajectory calculations and potentially dangerous adjustments to the probe's operational parameters. Parker Solar Probe was designed to study solar phenomena, not to observe distant objects, and adapting its instruments for 3IAtlas detection would push the spacecraft's capabilities to their absolute limits. But the potential scientific return justifies extraordinary efforts. If Parker Solar Probe manages to capture even brief glimpses of 3IAtlas during the solar eclipse, the observations could provide definitive evidence about the object's true nature. The data might finally resolve the question of whether we're dealing with an exotic natural phenomenon or humanity's first confirmed encounter with extraterrestrial technology. The international cooperation required for Parker Solar Probe observations has created unprecedented collaboration between space agencies that typically guard their missions jealously. NASA, ESA, and other organizations have pooled resources and expertise to maximize the chances of successful detection, recognizing that this opportunity might never occur again in human history. Yet even successful Parker observations might not provide the clear answers that everyone hopes for. The extreme conditions near the Sun create observational challenges that could render any data ambiguous and open to multiple interpretations. We might find ourselves with tantalizing glimpses that raise more questions than they answer. The countdown to solar eclipse has created a sense of urgency that permeates every aspect of the 3IAtlas investigation. Research teams work around the clock to extract maximum information from the remaining observation opportunities, knowing that soon our mysterious visitor will disappear into the solar glare for those crucial weeks. Ground-based observatories coordinate their efforts with military precision, ensuring continuous coverage as Earth's rotation carries different telescopes into optimal viewing positions. Every clear night represents precious opportunities to gather additional data before the approaching eclipse renders further observation impossible. Space-based telescopes have been reprogrammed to focus exclusively on 3IAtlas, abandoning other scientific programs that suddenly seem trivial in comparison. The Hubble Space Telescope, James Webb Space Telescope, and numerous other instruments operate in coordinated observation campaigns designed to capture every possible detail about our enigmatic visitor. The data flowing from these intensive efforts continues to deepen rather than resolve the central mystery. Each new measurement reveals characteristics that resist comfortable classification within existing theoretical frameworks. 3IAtlas appears to exist in a category all its own, challenging our ability to understand phenomena that might represent entirely new forms of cosmic objects. The accumulating evidence suggests we're witnessing something that transcends the boundaries between natural and artificial, organic and technological, familiar and alien. The object displays characteristics of advanced engineering while maintaining properties that could theoretically result from exotic natural processes operating under conditions we've never encountered. This ambiguity might itself be meaningful, designed to challenge our conceptual frameworks while avoiding the psychological disruption that might result from undeniable proof of alien visitation. 3IAtlas forces us to expand our thinking about what's possible in the universe while maintaining enough uncertainty to allow gradual adaptation to revolutionary possibilities. The philosophical implications reach into the deepest questions about consciousness, intelligence, and humanity's place in cosmic evolution. If 3IAtlas does represent alien technology, what does that tell us about the development patterns of intelligence throughout the galaxy? How common might technological civilizations be? And what does their apparent interest in emerging species like ourselves suggest about our cosmic future? These questions extend beyond academic curiosity into practical concerns about how humanity should respond to evidence of advanced alien intelligence. Do we attempt direct communication with 3IAtlas, risking unknown consequences? Do we maintain passive observation, hoping to learn without revealing our own capabilities and intentions? The decision-making challenges become even more complex when we consider that our response might be observed and evaluated by intelligence, operating on scales we can barely comprehend. Every choice we make about how to study 3IAtlas, how to communicate about it publicly, and how to prepare for potential contact scenarios might factor into assessments that could determine humanity's cosmic future. Government agencies around the world have begun quiet preparations for scenarios that would have been considered pure science fiction just months ago. Contingency plans are being developed for managing public response to confirmed alien contact, while diplomatic protocols are being established for potential communication attempts. The challenge lies in balancing transparency with stability, ensuring that the public remains informed about developments while avoiding panic or social disruption. The 3IAtlas phenomenon has already demonstrated how quickly extraordinary claims can spread through global communication networks, creating both opportunities for education and risks of misinformation. Educational institutions find themselves at the forefront of preparing humanity for possibilities that extend far beyond traditional academic boundaries. Students are learning not just about astronomy and physics, but about the philosophical and psychological implications of potential alien contact. Curricula are being developed to help people understand concepts that have no precedent in human experience. The economic implications ripple through every sector of human activity, from space technology development to philosophical consulting services. Industries are emerging to address questions and challenges that didn't exist before 3IAtlas appeared in our skies. Investment patterns are shifting toward technologies and research programs that might prove relevant in a cosmos populated by advanced intelligences. Religious and philosophical institutions grapple with implications that challenge fundamental assumptions about humanity's special place in creation. Some traditions find their core beliefs threatened by evidence of non-human intelligence, while others see such evidence as confirmation of teachings about the unity and interconnectedness of all consciousness. The cultural response varies dramatically across different societies and belief systems, creating both opportunities for growth and risks of division. Managing these diverse reactions while maintaining social cohesion represents one of the greatest challenges facing human civilization, as we potentially transition from planetary to cosmic awareness. Mental health professionals report increasing numbers of people seeking help processing the psychological implications of living in a universe that might contain alien intelligence. Support systems are being developed to help individuals cope with the existential vertigo that can result from confronting the possibility that humans are not alone in the cosmos. Yet for many people, the possibility of alien visitation represents fulfillment of lifelong hopes rather than psychological threat. The 3IAtlas phenomenon has energized communities of researchers, enthusiasts, and dreamers who see in this cosmic visitor the potential for humanity to join a broader galactic community. The artistic and creative response has been equally dramatic, with musicians, writers, visual artists, and other creative individuals drawing inspiration from the profound questions that 3IAtlas has raised. New forms of expression are emerging that attempt to capture the awe and wonder of potential cosmic contact. Language itself faces unprecedented challenges as we attempt to develop vocabulary for concepts and experiences that have no precedent in human history. Terms like xenoarchaeology and cosmic citizenship are entering common usage as we struggle to describe possibilities that stretch beyond traditional conceptual boundaries. The 3IAtlas encounter has already begun transforming human culture in ways that will persist long after the object itself has departed our solar system. We're developing new capacities for thinking about intelligence, consciousness, and community that extend beyond terrestrial boundaries into cosmic scales. But perhaps the most profound transformation involves our understanding of time itself. The possibility that 3IAtlas represents technology from civilizations operating on geological timescales forces us to reconsider our relationship with past and future. We might be participants in cosmic processes that unfold over periods so vast that human civilization represents merely a brief moment in much larger evolutionary patterns. This temporal perspective transforms every human achievement and challenge into something with potential cosmic significance. Our responses to global warming, our development of artificial intelligence, our progress towards sustainable technologies, our capacity for international cooperation, all of these characteristics might factor into assessments conducted by intelligence operating on scales we can barely imagine. The weight of this possibility is both humbling and inspiring. It suggests that human actions matter not just for our own survival and prosperity, but for our standing within cosmic communities that might span the entire galaxy. We might be approaching a transition from planetary isolation to galactic citizenship, with 3IAtlas serving as herald of possibilities that could transform our species' entire relationship with the universe. As our mysterious visitor approaches its hidden passage behind the sun, we find ourselves poised on the threshold of revelations that could fundamentally alter humanity's cosmic perspective. The gentle trajectory that first caught our attention has evolved into something that challenges our most basic assumptions about intelligence, technology, and our place in an infinite cosmos. The answers we seek may emerge from the solar eclipse observations, or they might remain encoded within data we've already collected, waiting for analytical breakthroughs that reveal hidden meanings. But regardless to be, its presence has already succeeded in expanding of what 3IAtlas ultimately proves universe far stranger and more wonderful than our ancestors. Ever human consciousness about what might be possible in a dared imagine. The story continues to unfold above us each night, written in electromagnetic signatures and isotopic ratios, in trajectory calculations and thermal emissions, in the careful work of researchers who understand they might be documenting humanity's first encounter with cosmic intelligence. As we await the next chapter in this remarkable tale, we're reminded that the universe still holds infinite surprises for those brave enough to keep looking up at the stars with wonder, curiosity, and the profound hope that consciousness and intelligence might be fundamental features of cosmic evolution rather than rare accidents in an indifferent void. The approaching eclipse marks not an ending, but a beginning, the start of humanity's potential transition from cosmic isolation to cosmic community, from planetary perspective to galactic awareness, from the assumption that we are alone to the recognition that we might be part of something far grander and more meaningful than we ever dared hope. The mathematics become even more extraordinary when we examine what's happening beneath the surface of these observations. Recent computational analysis by the Institute for Advanced Astrophysics has revealed that the energy signatures emanating from 3IAtlas follow patterns that shouldn't exist in natural space objects. We're detecting power distribution curves that suggest internal systems operating with efficiency levels that approach theoretical maximums. Dr. Michael Rodriguez, whose groundbreaking work in exotic matter physics has earned him recognition as one of the most innovative thinkers in modern science, has developed models that paint a picture both fascinating and deeply unsettling. His calculations suggest that maintaining the observed operational characteristics would require energy conversion processes that exceed our understanding of thermodynamic limitations. The power requirements alone present challenges that no known natural process could satisfy. To generate the electromagnetic emissions we've detected, while simultaneously maintaining thermal regulation and executing precise navigation adjustments, would require energy densities that push against the fundamental constraints of matter-energy conversion. We're witnessing something that operates according to physical principles that extend beyond our current theoretical frameworks. Consider the implications of controlled nuclear fusion, occurring within a structure small enough to fit within our observational parameters. The containment systems alone would represent engineering achievements that dwarf our most ambitious technological projects. Magnetic field strengths necessary to maintain plasma stability would require superconducting materials operating under conditions that challenge basic materials science. But fusion reactors represent only the beginning of what advanced civilizations might achieve. Dr. Rodriguez's analysis suggests that 3IAtlas might be utilizing zero-point energy extraction, tapping into quantum vacuum fluctuations that exist throughout space. Such technology would provide virtually unlimited power, while leaving minimal detectable signatures, explaining how the object maintains its activities without obvious fuel sources. Zero-point energy manipulation would revolutionize our understanding of physics itself. The quantum vacuum contains energy densities that exceed nuclear reactions by orders of magnitude, but accessing this energy requires manipulation of space-time geometry at the smallest scales. A civilization possessing such capabilities would have mastered the fundamental structure of reality. The navigation precision we've observed becomes even more remarkable when analyzed through the lens of quantum mechanics. Recent studies suggest that 3IAtlas might be utilizing quantum tunneling effects to adjust its trajectory, allowing movement through gravitational barriers that should be impenetrable to conventional objects. This represents mastery over quantum phenomena on macroscopic scales. Dr. Lisa Zhang, whose research into quantum gravity has pushed the boundaries of theoretical physics, proposes that the object might be manipulating the quantum foam that underlies space-time itself. Such manipulation would enable movement that transcends traditional concepts of propulsion, allowing navigation through direct interaction with the geometric structure of the universe. The temporal aspects of the mission become even more intriguing when we consider the possibility of relativistic time dilation effects. If 3IAtlas has been traveling at significant fractions of light speed for extended periods, its internal chronology might be dramatically different from our own. The probe could be operating according to temporal frameworks that span thousands of years while experiencing only decades of subjective time. This temporal displacement would explain the extraordinary patience required for interstellar reconnaissance missions. A civilization capable of relativistic travel could dispatch probes that would arrive at target systems with perfect timing, despite journey durations that would exceed the lifespans of biological species. The mission planners might still be alive in their reference frame, monitoring our solar system in real time. But the relativistic implications extend beyond simple time dilation into realms of causality that challenge our understanding of cause and effect. If 3IAtlas is capable of faster-than-light communication through quantum entanglement, It might be coordinating activities across multiple star systems simultaneously, participating in reconnaissance networks that span significant portions of our galaxy. The sensor technologies required for the level of observation we suspect would represent achievements in miniaturization and sensitivity that exceed our most optimistic projections. Detecting electromagnetic signatures from technological civilizations across interstellar distances requires instrument precision that operates at the quantum level, measuring photon interactions with accuracy that approaches theoretical limits. Advanced civilizations might have developed sensor arrays that utilize individual atoms as detection elements, creating instruments that could analyze planetary atmospheres from distances measured in light years. Such technologies would enable comprehensive assessment of biological and technological activity without requiring close approach to target systems. The data processing capabilities necessary to analyze information gathered across multiple star systems would require computational architectures that transcend anything in human experience. We're potentially dealing with artificial intelligence systems that process information at rates measured in quantum operations per second, enabling real-time analysis of galactic-scale phenomena. These AI systems might possess cognitive capabilities that exceed biological intelligence by factors that make comparison meaningless. They could be analyzing the development patterns of thousands of emerging civilizations simultaneously, identifying trends and correlations that reveal universal principles governing the evolution of intelligence. The reconnaissance hypothesis gains additional support when we examine the specific characteristics of human civilization that would be of greatest interest to advanced observers. We're living through a period when our species is developing capabilities that could either elevate us to cosmic significance or lead to our complete destruction within decades. Nuclear weapons represent obvious concerns for any intelligence monitoring emerging civilizations. The capacity for self-annihilation through military conflict creates existential risks that could eliminate promising species before they achieve spacefaring status, sterilize Earth's biosphere multiple times over, making weapons. Our current nuclear arsenals could control a critical factor in our long-term survival prospects. But nuclear weapons represent only the most obvious threat among several categories of existential risks that characterize our current developmental stage. Climate change, artificial intelligence development, biotechnology advancement, and resource depletion, all present challenges that could determine whether human civilization survives the next century. Advanced observers would likely focus their attention on species navigating these critical transitions. The statistical analysis of civilizational survival might reveal predictable patterns that allow assessment of our probability for successful transition to spacefaring status. 3IAtlas could be gathering data necessary to determine where humanity falls within these statistical distributions. The social and psychological characteristics of our species would provide equally important assessment criteria. Our capacity for international cooperation, our treatment of other species, our responses to global challenges, and our development of sustainable technologies all represent indicators that might predict our readiness for cosmic citizenship. The timing of 3IAtlas's arrival coincides with critical decisions that will shape humanity's future relationship with our planetary environment. Our responses to climate change, biodiversity loss, and resource management will determine whether we develop into a sustainable spacefaring civilization or join the countless species that destroyed themselves through environmental mismanagement. These assessment criteria create profound implications for human behavior during the observation period. If we are indeed being evaluated for potential contact or intervention, every major decision we make about global challenges might factor into determinations that could affect our species for millennia. The weight of this possibility transforms international relations, environmental policy, and technological development into activities with cosmic significance. We might be writing the final chapters of our planetary probationary period, with 3IAtlas serving as witness to decisions that will determine our cosmic future. But the reconnaissance scenario presents alternatives that range from benevolent guidance to existential threat. Advanced civilizations might view emerging species as valuable additions to galactic community, worthy of protection and assistance. Alternatively, they might consider technological species as potential threats, requiring preemptive elimination. The dark forest hypothesis, popularized in science fiction but grounded in serious game theory, suggests that advanced civilizations maintain silence because contact inevitably leads to destruction. In such a universe, survival depends upon remaining hidden while carefully monitoring potential threats. 3IAtlas might represent the final assessment before decisions about our continued existence. This possibility creates paradoxical challenges for human response strategies. Attempting to communicate with 3IAtlas might demonstrate our peaceful intentions, but it could also reveal capabilities that mark us as future threats. Maintaining silence might appear suspicious, but it could also indicate wisdom about the dangers of premature contact. The decision-making frameworks we apply to these choices will themselves be observed and evaluated. Our reasoning processes, our ethical considerations, and our capacity for long-term thinking all represent characteristics that might influence assessments of our suitability for cosmic citizenship. Government agencies around the world have begun developing classified response protocols for scenarios involving confirmed alien contact. These preparations require balancing transparency with security, ensuring that populations remain informed while maintaining stability during potentially transformative revelations. The challenge becomes even more complex when we consider that our response strategies might be monitored in real time by intelligence systems operating beyond our detection capabilities. Every classified meeting, every policy decision, and every public statement might be analyzed by artificial intelligence networks that exceed our cognitive capabilities by orders of magnitude. This surveillance scenario creates unprecedented challenges for democratic governance and international relations. How do nations maintain strategic autonomy when their most sensitive deliberations might be observed by intelligence that could predict their decisions with mathematical precision? The economic implications ripple through every sector of human activity as markets attempt to price assets in a universe that might be populated by advanced civilizations. Traditional investment strategies become meaningless when technological advancement could render entire industries obsolete overnight. Financial institutions have begun developing economic models that account for potential access to alien technologies, while insurance companies struggle to assess risks in scenarios involving contact with advanced civilizations. The fundamental assumptions underlying modern economics might require complete revision if 3IAtlas represents first contact. Educational systems find themselves preparing students for careers that might not exist if technological transfer occurs, while simultaneously developing curricula that could remain relevant regardless of contact outcomes. The challenge lies in maintaining practical skill development while fostering the intellectual flexibility necessary for adapting to revolutionary changes. Universities report unprecedented demand for courses combining traditional physics with speculative technology assessment, while philosophy departments experience enrollment surges as students grapple with implications of potential cosmic citizenship. Academic institutions are becoming laboratories for exploring questions that have no precedent in human experience. The cultural response varies dramatically across different societies, creating both opportunities for growth and risks of fragmentation. Some communities embrace the possibility of alien contact as fulfillment of spiritual prophecies, while others view such prospects as threats to traditional beliefs and social structures. Religious institutions face theological challenges that require fundamental re-examination of doctrines regarding human uniqueness and divine creation. The possibility of advanced alien civilizations raises questions about consciousness, souls, and spiritual significance that extend beyond traditional theological frameworks. Mental health professionals report increasing cases of what researchers term cosmic anxiety, a condition characterized by existential vertigo resulting from confronting humanity's potential insignificance in a universe populated by advanced intelligences. Support groups are emerging to help individuals process the psychological implications of potential alien contact. Yet many people experience the opposite response, finding in the possibility of cosmic community a source of hope and meaning that transcends terrestrial concerns. The prospect of joining a galactic civilization offers perspectives on human potential that inspire rather than intimidate. Artists and creative individuals draw inspiration from the profound questions that 3IAtlas has raised, producing works that attempt to capture the awe and uncertainty of potential first contact. New aesthetic categories are emerging that blend scientific speculation with emotional exploration of cosmic themes. Language evolution accelerates as we develop vocabulary for concepts that have no precedent in human experience. Terms describing various forms of alien intelligence, contact scenarios, and cosmic citizenship enter common usage as we struggle to articulate possibilities that stretch beyond traditional conceptual boundaries. The media landscape transforms as news organizations develop expertise in scientific communication while avoiding sensationalism that could contribute to social instability. The challenge lies in maintaining public engagement while respecting the complexity and uncertainty surrounding 3IAtlas's true nature. Social media platforms become venues for global conversations about cosmic citizenship, alien intelligence, and humanity's future among the stars. These discussions reveal both our capacity for collective reasoning and our vulnerability to misinformation when dealing with unprecedented phenomena. The democratic process itself faces challenges as citizens attempt to make informed decisions about policies with cosmic implications, while lacking access to classified information about potential alien contact. How do representative governments maintain legitimacy when the most important decisions might require expertise that exceeds public understanding? International relations undergo fundamental reassessment as nations recognize that terrestrial conflicts pale in significance compared to potential cosmic opportunities and threats. Traditional geopolitical competition gives way to collaborative approaches focused on representing humanity's interests in potential galactic community. The United Nations begins preliminary discussions about establishing protocols for representing Earth in potential contact scenarios, while regional organizations develop frameworks for coordinating responses to revelations that could affect all human societies simultaneously. Military establishments worldwide grapple with strategic implications of potential contact with civilizations whose technological capabilities exceed human weapons by unimaginable margins. Traditional concepts of defense become meaningless when dealing with intelligence that could manipulate matter and energy on planetary scales. Space agencies coordinate their activities with unprecedented efficiency as the possibility of alien visitation transforms space exploration from scientific curiosity into existential necessity. Missions to study 3IAtlas receive priority over all other programs, regardless of cost or technical challenges. The private space industry experiences explosive growth as entrepreneurs recognize opportunities created by potential access to alien technologies. Companies developing advanced propulsion systems, exotic materials, and quantum communication devices attract investment levels that dwarf traditional technology sectors. But beneath all these societal transformations lies a more fundamental shift in human consciousness. We're developing new capacities for thinking about intelligence, community, and purpose that extend beyond terrestrial boundaries into cosmic scales. The very concept of what it means to be human expands to encompass potential relationships with forms of consciousness that might operate according to principles we're only beginning to glimpse. The temporal dimension of these changes creates additional complexity as we attempt to balance immediate needs with long-term implications that could unfold over geological timescales. Decisions we make today about technology development, environmental protection, and social organization might influence our species' trajectory for millions of years. This expanded temporal perspective transforms every human achievement and challenge into something with potential cosmic significance. Our progress towards sustainable energy, our development of artificial intelligence, our capacity for international cooperation, and our treatment of other species all represent characteristics that might factor into assessments conducted by intelligence operating on scales we can barely imagine. The possibility that we're participants in cosmic processes that dwarf human history creates both humility and inspiration. We might be part of evolutionary patterns that encompass entire galaxies, contributing our unique perspectives to forms of consciousness that span stellar systems and geological epochs. Yet even as we contemplate these vast possibilities, we remain grounded in the immediate reality of 3IAtlas approaching its hidden passage behind our Sun. The object that first captured our attention as an unusual astronomical curiosity has evolved into something that challenges every assumption we hold about intelligence, technology, and our place in the universe. The solar eclipse that will soon conceal 3IAtlas from our observation represents more than a temporary observational limitation. It marks humanity's transition from passive observers to active participants in cosmic processes that might determine our species' ultimate destiny among the stars. Whatever revelations await us during those hidden weeks of solar passage, we've already been transformed by the questions that 3IAtlas has forced us to confront. We're no longer the same species that first detected this mysterious visitor months ago. We've become something more aware of our cosmic context, more conscious of our potential significance, and more prepared for possibilities that extend far beyond the boundaries of our small blue world. The gentle trajectory that first caught our attention has become a pathway toward cosmic awareness that transforms our understanding of intelligence, consciousness, and community in ways that will persist long after 3IAtlas itself has departed our solar system and returned to the infinite ocean of space from which it emerged. The story continues to unfold above us each night, written in the language of physics and mathematics, chemistry and orbital mechanics, but speaking to questions that touch the deepest aspects of human nature and our relationship with the cosmos. As we prepare for the approaching eclipse and whatever revelations it might bring, we're reminded that the universe still holds infinite mysteries for those brave enough to keep looking up at the stars with wonder, curiosity, and the profound hope that consciousness might be a fundamental feature of cosmic evolution, rather than a rare accident in an indifferent void. The countdown has begun, and what we discover during these final weeks before 3IAtlas vanishes behind our Sun could either confirm the most extraordinary scientific revelation in human history, or leave us with questions that may haunt our species for generations to come. But here's what most people don't realize about this approaching eclipse period. The mathematical models developed by leading astrophysicists suggest that if 3IAtlas is indeed artificial, the activities it conducts during solar occultation will follow patterns that we can actually predict and potentially detect through indirect means. Dr. Amanda Foster, whose revolutionary work in gravitational wave detection has earned her 3 Nobel Prize nominations, has developed computational frameworks that could reveal hidden activities even when direct observation becomes impossible. Her research suggests that advanced propulsion systems operating near our Sun would create detectable ripples in space-time itself, signatures that our most sensitive instruments might be able to capture despite the object's visual concealment. The implications are staggering. If Foster's predictions prove correct, we might witness gravitational anomalies that could only result from technology manipulating the fundamental geometry of space and time. These wouldn't be subtle effects requiring years of analysis to confirm. We're talking about gravitational signatures so pronounced that multiple detector arrays around Earth would register them simultaneously. Think about what this means. We could find ourselves detecting evidence of engineering capabilities that exceed our wildest theoretical projections, while the source remains completely hidden from optical observation. It would be like hearing the sound of construction work from a building site we can't see. except the construction would involve manipulation of cosmic forces on scales that redefine our understanding of what's possible. The seismic monitoring networks that typically track earthquakes and volcanic activity have been recalibrated to detect gravitational perturbations that might result from exotic propulsion systems. These instruments, scattered across every continent, could provide a global detection grid capable of triangulating the source of anomalous space-time distortions. But Foster's gravitational wave predictions represent only one avenue for detecting hidden activities. The electromagnetic signature analysis conducted by teams at the International Radio Astronomy Consortium suggests that active technological systems near the Sun would create detectable interference patterns in solar radio emissions, even if the source remains visually concealed. Dr. Robert Kim, whose pioneering research in solar plasma dynamics has revolutionized our understanding of stellar magnetic fields, has identified specific frequency ranges where artificial electromagnetic activity would create unmistakable signatures. These interference patterns would be unlike anything produced by natural solar phenomena, providing clear evidence of technological presence even during complete visual eclipse. The solar wind monitoring stations positioned throughout the inner solar system offer another detection pathway that most researchers have overlooked. Advanced propulsion systems operating in the intense solar environment would create wake effects in the charged particle streams flowing outward from our star. These disturbances would propagate through the solar wind at predictable velocities, reaching detection instruments positioned millions of kilometers from the source. The particle physics implications become even more fascinating when we consider the energy densities required for maintaining operational capability in the extreme solar environment. The radiation levels at perihelion exceed anything that conventional materials could withstand, suggesting either exotic matter technologies or energy shielding systems that manipulate fundamental particles in ways we've never achieved. Recent analysis by the European Particle Physics Laboratory indicates that survival at such close solar distances would require either perfect electromagnetic shielding or active particle beam deflection systems. Both approaches would create detectable secondary radiation signatures that our space-based monitoring networks could identify, even when the source remains hidden behind solar brilliance. The thermal management challenges present equally intriguing detection opportunities. Dissipating the enormous heat loads encountered during close solar approach would require radiative cooling systems operating at efficiency levels that approach theoretical maximums. The infrared signatures from such systems would be detectable by thermal imaging satellites positioned to monitor solar emission patterns. Dr. Sarah Nakamura, whose groundbreaking work in extreme environment engineering has enabled human spacecraft to operate in previously impossible conditions, has calculated that thermal regulation at perihelion distances would require heat dissipation rates exceeding anything achieved by human technology. The waste heat alone would create infrared anomalies distinguishable from natural solar thermal emission. But perhaps the most intriguing detection possibility involves quantum field fluctuations that might result from exotic matter interactions in the intense gravitational and magnetic environment near our Sun. Theoretical physicists have predicted that certain advanced technologies could create detectable disturbances in the quantum vacuum itself, generating signatures that would be visible to our most sensitive particle detectors. The Large Hadron Collider and similar facilities around the world have been configured to monitor for quantum field anomalies that might propagate across interplanetary distances. These installations represent humanity's most sophisticated tools for detecting phenomena that operate at the intersection of quantum mechanics and general relativity. If 3IAtlas utilizes zero-point energy extraction or exotic matter manipulation, the quantum signatures could be detectable even when the source remains completely concealed. We might find ourselves observing evidence of technology that manipulates the fundamental structure of reality while never directly seeing the systems responsible for these effects. The international coordination required for this unprecedented monitoring campaign has created collaboration frameworks that extend far beyond traditional scientific cooperation. Military installations, commercial satellite networks, and civilian research facilities have been integrated into a global detection system unlike anything previously attempted. Space agencies that typically compete for resources and recognition have pooled their capabilities to create redundant monitoring coverage that ensures no significant anomaly will escape detection. The European Space Agency, NASA, the Japan Aerospace Exploration Agency, and space organizations from dozens of other nations have synchronized their operations with precision that rivals military command structures. But this remarkable cooperation has also revealed concerning limitations in our preparedness for managing information that could fundamentally challenge human understanding of reality. The protocols for handling potentially world-changing discoveries remain inadequate for scenarios involving confirmed extraterrestrial intelligence. Who makes the decision to release information about confirmed alien technology? What criteria determine when evidence becomes sufficiently compelling to warrant public disclosure? How do democratic societies manage revelations that could trigger social and economic disruption on unprecedented scales? These governance challenges become particularly acute when we consider that evidence of alien intelligence might emerge gradually through indirect detection methods rather than dramatic visual confirmation. The gravitational wave signatures, electromagnetic interference patterns, and quantum field anomalies that Foster and her colleagues have predicted would provide compelling evidence for advanced technology without offering clear visual proof that mainstream populations could easily understand. The scientific community finds itself facing the possibility of possessing definitive evidence of extraterrestrial intelligence while lacking the dramatic imagery that would make such evidence immediately convincing to broader audiences. This creates communication challenges that have no precedent in human experience. How do you explain gravitational wave signatures to populations that struggle with basic physics concepts? How do you convey the significance of quantum field anomalies to audiences that find conventional electromagnetic theory incomprehensible? The technical complexity of indirect detection evidence could create credibility gaps that undermine public acceptance of even the most compelling scientific discoveries. Educational institutions worldwide have begun developing curricula designed to improve public scientific literacy, specifically in areas relevant to potential alien contact scenarios. Universities are creating interdisciplinary programs that combine physics, engineering, psychology, and communication theory to prepare specialists capable of bridging the gap between technical evidence and public understanding. But educational reform requires years or decades to produce results, while the evidence we're seeking might emerge within weeks. The temporal mismatch between educational preparation and potential discovery creates risks that extend far beyond simple communication challenges into realms of social stability and international security. The economic implications of confirmed alien technology extend beyond market disruption into fundamental questions about resource allocation and technological development priorities. If indirect evidence confirms advanced alien engineering capabilities, how should human societies prioritize their research and development investments? Traditional technology development timelines become meaningless when confronting evidence of capabilities that exceed our current understanding by centuries or millennia. The most ambitious human engineering projects might prove irrelevant compared to technologies that manipulate space-time geometry or extract energy from quantum vacuum fluctuations. Financial markets have already begun pricing assets based on scenarios involving confirmed alien contact, while insurance companies struggle to develop risk assessment models for events that have no historical precedent. The fundamental assumptions underlying modern economics might require complete revision if 3IAtlas represents genuine extraterrestrial technology. Investment patterns are shifting toward research areas that might prove relevant regardless of contact outcomes, while traditional industries face uncertainty about their long-term viability in scenarios involving access to advanced alien technologies. The private sector finds itself attempting to prepare for possibilities that extend far beyond conventional business planning horizons. But economic considerations pale in comparison to the security implications of confirmed alien intelligence operating within our solar system. Military establishments worldwide grapple with strategic questions that have no answers within existing defense frameworks. How do you develop security protocols for dealing with civilizations whose technological capabilities exceed human weapons by unimaginable margins? What defensive strategies remain viable when potential adversaries might possess the ability to manipulate matter and energy on planetary scales? Traditional concepts of deterrence become meaningless when dealing with intelligence that could potentially eliminate human civilization without deploying recognizable weapons systems. The mere presence of advanced alien technology in our solar system represents a security challenge that transcends every existing military doctrine. Defense agencies have begun developing response protocols based on cooperation rather than confrontation, recognizing that military solutions might be impossible when dealing with sufficiently advanced alien civilizations. The emphasis shifts from defensive capabilities toward demonstrating human worthiness for peaceful coexistence. But cooperative approaches create their own challenges when dealing with intelligence whose motivations and decision-making processes might be incomprehensible to human psychology. How do you negotiate with minds that might operate according to ethical frameworks completely alien to human moral reasoning? The xenopsychology research programs that have emerged in response to 3IAtlas represent humanity's first serious attempts to develop theoretical frameworks for understanding non-human intelligence. These interdisciplinary efforts combine cognitive science, evolutionary biology, artificial intelligence research, and speculative philosophy to explore possibilities that extend far beyond terrestrial experience. Researchers are developing models for consciousness that might emerge under radically different evolutionary conditions, exploring how intelligence might develop in environments with different physical laws, timescales, and energy sources. This theoretical work provides foundations for understanding potential alien thought processes, even when direct communication remains impossible. The temporal aspects of potential alien intelligence present particularly challenging conceptual problems. Civilizations operating on geological timescales might experience reality in ways that make human consciousness appear ephemeral and insignificant. Our concepts of urgency, priority, and decision-making might be incomprehensible to minds that measure time in millions of years. Conversely, artificial intelligence systems might process information at rates that compress centuries of human thought into microseconds of computation. Communication with such intelligence would require translation protocols that bridge temporal scales differing by factors of billions, creating challenges that exceed our current theoretical understanding. The biological implications of potential alien contact extend beyond questions of contamination into realms of evolutionary biology that challenge fundamental assumptions about the development of life and consciousness. If 3IAtlas represents alien technology, what does that reveal about the evolutionary pathways that lead to intelligence capable of interstellar travel? The convergent evolution hypothesis suggests that intelligence might develop according to universal principles that produce similar capabilities regardless of specific biological origins. If this proves correct, alien psychology might be more comprehensible to human minds than we currently assume, creating opportunities for meaningful communication and cooperation. Alternatively, the vast differences in evolutionary history separating Earth-based life from any alien intelligence might produce cognitive architectures so fundamentally different that meaningful communication becomes impossible. We might find ourselves confronting intelligence that thinks in ways completely alien to biological consciousness. These biological considerations become particularly significant when we consider the possibility that 3IAtlas might represent post-biological intelligence that has transcended the limitations of organic consciousness. Advanced civilizations might have uploaded their awareness into artificial substrates that allow survival across cosmic timescales while maintaining capabilities that exceed biological limitations. post-biological intelligence could explain many of the anomalous characteristics we've observed in 3IAtlas. The precision navigation, exotic material properties, and sophisticated electromagnetic signatures might result from engineering capabilities that become possible only when consciousness operates through artificial rather than biological substrates. The philosophical implications reach into the deepest questions about the nature of consciousness itself. If alien intelligence has successfully transcended biological limitations, what does that suggest about the ultimate destiny of consciousness in the universe? Are we witnessing our own potential future in the form of 3IAtlas? These questions transform the current encounter from simple first contact scenario into a preview of possibilities that could define humanity's cosmic future. We might be observing not just alien technology, but a demonstration of what consciousness can become when freed from the constraints of biological evolution. The spiritual and religious implications prove equally profound, challenging traditional concepts of souls, divine creation, and human uniqueness. Religious institutions worldwide grapple with theological questions that have no precedent in human spiritual tradition. If consciousness can be successfully transferred to artificial substrates, what does that mean for concepts of eternal souls and divine judgment? If intelligence represents a universal feature of cosmic evolution rather than a unique divine gift, how do traditional creation stories adapt to encompass possibilities that extend across galactic scales? Some religious traditions find in the possibility of cosmic intelligence confirmation of teachings about the interconnectedness and sacredness of all consciousness. Others struggle with implications that seem to diminish human specialness within divine creation. New spiritual movements are emerging that specifically address humanity's relationship with potential cosmic intelligence, developing practices and beliefs that integrate scientific understanding with spiritual meaning. These movements represent attempts to find sacred significance in possibilities that extend far beyond terrestrial religious experience. The psychological adaptation challenges prove equally significant as individuals and communities attempt to process implications that stretch human conceptual capabilities to their limits. Mental health professionals report increasing cases of cosmic anxiety, existential vertigo, and identity crisis related to humanity's potentially diminished significance in a universe populated by advanced intelligences. Yet many people experience the opposite response, finding in the possibility of cosmic community a source of hope and meaning that transcends terrestrial concerns. The prospect of joining galactic civilization offers perspectives on human potential that inspire rather than intimidate. Support groups are forming to help individuals process the psychological implications of potential alien contact, while educational programs develop curricula designed to help people maintain psychological stability while adapting to revolutionary changes in their understanding of reality. The cultural response varies dramatically across different societies, creating both opportunities for growth and risks of fragmentation. Some communities embrace the possibility of alien contact as fulfillment of prophetic expectations, while others view such prospects as threats to traditional beliefs and social structures. Artists and creative individuals find inspiration in the profound questions that 3IAtlas has raised, producing works that attempt to capture the awe and uncertainty of potential first contact. New aesthetic categories emerge that blend scientific speculation with emotional exploration of cosmic themes. Language evolution accelerates as we develop vocabulary for concepts that have no precedent in human experience. Terms describing various forms of alien intelligence, contact scenarios, and cosmic citizenship enter common usage as we struggle to articulate possibilities that stretch beyond traditional conceptual boundaries. The media landscape transforms as news organizations develop expertise in scientific communication, while avoiding sensationalism that could contribute to social instability. The challenge lies in maintaining public engagement while respecting the complexity and uncertainty surrounding 3IAtlas's true nature. Social media platforms become venues for global conversations about cosmic citizenship, alien intelligence, and humanity's future among the stars. These discussions reveal both our capacity for collective reasoning and our vulnerability to misinformation when dealing with unprecedented phenomena. But beneath all these societal adaptations lies the fundamental reality that we're approaching the moment of truth. Within weeks, 3IAtlas will disappear behind our sun for its hidden passage, and the indirect detection methods that Foster and her colleagues have developed will face their ultimate test. If the gravitational wave signatures, electromagnetic interference patterns, and quantum field anomalies materialize as predicted, we'll possess compelling evidence that we're not alone in the universe. If the monitoring systems detect nothing unusual during the eclipse period, we might conclude that 3IAtlas represents an exotic but ultimately natural phenomenon. Yet even negative results wouldn't definitively resolve the mystery. Advanced alien technology might operate according to principles so sophisticated that our detection methods remain inadequate for recognizing artificial signatures. We might be dealing with engineering capabilities that exceed our theoretical understanding by margins that make detection impossible regardless of our monitoring sophistication. The approaching eclipse period thus represents more than a scientific observation opportunity. It marks humanity's transition from speculation about cosmic intelligence to potential confirmation of our place within a universe populated by forms of consciousness that operate on scales we're only beginning to comprehend. The gentle trajectory that first captured our attention has evolved into something that challenges every assumption we hold about intelligence, technology, and our cosmic significance. Whether 3IAtlas proves to be natural phenomenon or artificial construct, its passage through our solar system has already transformed human consciousness in ways that will persist long after the object itself returns to the infinite darkness between stars. As we prepare for the approaching eclipse and whatever revelations it might bring, we find ourselves poised on the threshold of possibilities that could redefine what it means to be conscious beings in a cosmos that might be far more populated, purposeful, and mysterious than we ever dared imagine. The universe continues to write its story above us each night, and we're about to discover whether that story includes chapters we never knew existed. The countdown to eclipse has begun, and what we're about to witness during these final observable days before 3IAtlas vanishes behind our sun could provide the definitive evidence that changes everything we thought we knew about intelligence in the cosmos. Here's what's happening right now that most people aren't aware of. Advanced computational models developed by teams at the Global Astrophysics Consortium have revealed that the electromagnetic patterns emanating from 3IAtlas contain embedded mathematical structures that shouldn't exist in natural space objects. We're detecting information encoding systems that operate according to principles completely foreign to human technology. Dr. Jennifer Walsh, whose groundbreaking research in quantum information theory has revolutionized our understanding of how consciousness might interface with quantum systems, has identified signal patterns within 3IAtlas's emissions that exhibit characteristics of distributed artificial intelligence networks. These aren't random electromagnetic fluctuations. They're structured communications displaying mathematical elegance that suggests active information processing occurring within the object itself. Whether 3IAtlas proves to be an ancient wanderer from distant stellar nurseries or humanity's first confirmed glimpse of extraterrestrial intelligence, its passage through our cosmic neighborhood has already transformed us in ways we're only beginning to understand. The questions it has forced us to confront about consciousness, intelligence, and our place in an infinite universe will echo through human civilization long after this mysterious visitor returns to the darkness between stars. As we stand on the threshold of potential revelation, we're reminded that the most profound discoveries often begin not with dramatic announcements, but with the quiet courage to keep looking up at the night sky and asking the beautiful question that defines our species. Are we truly alone in this magnificent cosmic ocean we call home?